let's define an as the integral of e to the power nx over 1 plus e to x between 0 and 1. The question that we need to answer is that what's the limit of an as n gets bigger? In this kind of questions, especially when we have integrals, we can try to find some upper bounds and lower bounds, and we see their limits if we can. And here in our case, we can find that very easily if we can just pay attention to the values of the variable here. So in this case, x is between 0 and 1, and n can be any, and n is going to get bigger. We can work on that, and we can try to see if we can find some sequence that bounds up and another one that bounds down an, and we see their limits. To do that, we just gonna work on this function e to the power nx over 1 plus ex. We're given that x is between 0 and 1. Okay, when we raise everything to the power x, we're gonna have e to the power x is between 1 and e. Adding 1 to both sides, we're gonna have 1 plus ex is between 2 and 1 plus e. Inverting, we're gonna get 1 over 1 plus ex is bigger than 1 plus 1 over 1. Yes, over 1 over 1 plus e. Yes, that's right. And here it's gonna be 1/2, because when we are inverting, we need to switch the bounds, the order. Okay. And after that, we can just, since e and x is bigger than 0, we can multiply by it both sides without affecting the order here. So we have e to nx over 1 plus e is less than e to nx over 1 plus e to the power x. And here it's going to be less than e to nx over 2. Okay, we multiply by e and x because it's positive. It's not going to affect the order. Now we are in this stage. We can integrate. Okay, so when we integrate, integrating, we have then we're gonna have an. Okay, because when we integrate between 0 and 1, we're gonna have an, our sequence. And here we're gonna have the integral between 0 and 1 of e and x over 2 dx. And on the left side, we're gonna have e to nx over 1 plus e between 0 and 1. Okay, let's first integrate. Since these two are very simple, we're gonna have e to nx over n times 1 plus e between 0 and 1 less than an and less than e to nx over n times 2 between 0 and 1. Let's do some evaluation. We're gonna have e to n minus 1 over n times 1 plus e less than an less than e to n minus 1 over 2n. Yes, and I think that's it. Okay, when we integrate, we're gonna have 1, and here we're gonna have, yes. Now we take the limit. Okay, taking the limit of all the sides here. When we are dealing with the exponential and some power of n, the exponential always wins. Okay, so this is combat between the two. So here this limit is going to be infinity. Okay, let's do this, and we're going to say why. The limit is going to be in plus infinity. Okay, we take the limit of this left side and the limit of this right side. We're gonna have the limit here as infinity. Why? I have shown in one of the previous videos that e to x over n to some power, e to e to n over n is always plus infinity as n goes to infinity, because the exponential wins. If you don't see it, okay, we can just apply the L'Hopital's rule to the function e to x over x. So here we have, when we take the limit, we have infinity over infinity. So we differentiate, we're going to have e to x over 1, and e to x goes to 1 to infinity as x goes to infinity. And this is very simple. And since the sequence is just a values, some values of the particular function, this is the limit. Okay, you can accept this one, that e to n over n is infinity, or you can prove it like this. It's very simple to prove using L'Hopital's rule. And the same thing on the right side. And this means that our limit here of this integral is gonna be infinity plus infinity. And that's how we do it. Sometimes we just integrate and we try to find an upper bound and a lower bound, and we take that limit. This is the squeeze theorem again. See, the squeeze theorem is very powerful, and using it with integration is very helpful. Thank you very much.